Well, welcome back, my geometrically minded minions. All right, so as we look at Geometric Foundations 3.1, notice this one's a point 1. That means if there's a point 1, there's probably going to be a point 2. So Geometric Foundations 3.1, this one's going to be on measuring segments. Now, we've already talked about segments. We know what they are. They are a part of a line. They have two endpoints. So we've looked at that. We found the distance between segments, or the distance between points on a number line. So we're going to take this a little bit step further and kind of delve into what it means when we're not just talking about on the coordinate plane. So that's where we're going today. So first of all, let's start with this. So looking at, we've got this number line up here, and we see where S is, and S is between -6 and -4, so that has to be -5. And we see where T is at 2, U is at 4, V is between 4 and 6, so it has to be at 5, and M is all the way over here at 8. So we got a couple of things we're being asked to find down here at the bottom, and they look really similar. So take a look, hit pause, put down what you think they mean, and then come back to me. Okay, well, so you've got here, and we're looking at them. Let's start at the bottom, since the bottom is the easiest. ST, notice this says ST equals. So this is talking about the distance from S to T. So this one down here at the bottom, this one right here, this is talking about the distance. So when you see it simply as those two letters there, no segment bar across the top, equals, it says the distance from S to T equals. When we look here and go, hey, all right, so that's -5 to 2. So we're looking at that distance is 7, and we'll call them centimeters here. So that's 7 centimeters when we look at that. So that's this distance right here. And no, distance is always positive, doesn't matter. We could have gone at TS, it's still going to be 7. Now look at the next one. The measure of segment ST. The measure, that's what that M stands for, the measure. So they want us to measure segment ST. Well, the measure of ST, if we were to measure it, well, this is at -5, this is at 2. The answer here is 7 centimeters. So these bottom two, they're asking the exact same thing. The measure of segment ST and the distance from S to T, both talking about that. Now, at the top one, notice this. It says segment ST equals. This is not asking for a number, okay? This one didn't ask us to measure the segment. It doesn't ask us the distance between them. It says that ST is equal to, in other words, ST is equal to in length what? That's what's going on here, okay? So this top one right here is saying ST is equal to what? Well, up here, the only thing that ST is equal to is itself, okay? So segment ST, it's not talking about a number. Numbers can be equal, okay? Numbers can be equal. We can set those and say something has a numeric value. But as far as a segment itself, it says ST is equal to, that's asking like, who are you equal to? Well, the answer is just yourself, okay? So it kind of brings in a term. Now, if we would have seen this symbol right here, is an equal to with a symbol, with this little swish symbol across the top, this is the symbol for congruent, okay? Congruent. Congruent, if you remember from last year, congruent means equal in, equal in measure. So two segments could be equal in measure there. So if we're looking at this, turn around and trying to find something else here, we could find another point here possibly that would be equal in measure to ST, and that's what it would be talking about. So congruent could be equal in measure to, but if you see equal, it's equating to a number system here. And just off the top of the head, what else? Let's see, that's something that's -5 to 2, that's something that's 7 away. Is there anything else here that's 7 away? Well, I guess we need to put another point in here. We could put some point in here and call it Q. And then we could say that QM, let's just put that one in. QM is congruent to ST. Those two are equal in measure, but they're not equal to each other. They're not the same. Okay, so this is what we were talking about here, equal versus congruent. And we said, like right here, it says that BC equals 4. And AB equals 4. Well, 4 can equal 4, okay? But that doesn't mean that this segment right here, segment AB, is equal to segment BC. They're two different things, okay? It's kind of, think of it like this, like you have two twins sitting in class. Okay? They may have the same hair color. They may have the same eye color. They may talk the same. They may act the same. They may wear the same clothes, but they're not equal. They're not the same person. So what we do is we would say then that although these numbers here are equal, we could say that 4 equals 4. Yes, 4 equals 4. But AB, if we're talking about the segment AB and segment BC, they're not equal to each other. They're congruent to each other. They have the same length. They have the same characteristics, but they are different. They are different sides. This side is different than this side. This side is different than this side. So numbers are equal. Segments, sides, things are congruent. So putting that one in there. So a couple of definitions, other things that we need to consider is midpoint. This is the location. This is the location. Halfway, 1/2 the distance between 2 points. Okay? This is a point itself. It's a location. It's a point that's halfway between the points. Now, you know, you have a midpoint formula. If you remember the midpoint formula that you learned, I guess this was in 8th grade, and it says that when you take x1 plus x2 and you divide it by 2, and you take y1 plus y2 and you divide it by 2, that coordinate is the midpoint. Well, guys, it's just an average. In midpoint, the only place we use midpoint is in a math class. Everywhere else in the world, we call that the average. You find midpoints in your bowling scores. You find the average. How do you find the average of your bowling scores? Well, you add the 2 up and you divide it by 2. How do you find your average test score? Well, you add the 2 test scores up and you divide by 2. How do you find your average on 2 anythings, two movie prices that you go to? Well, you add the 2 prices and you divide by 2. Well, that's what happens here. We're simply finding the average of the x values and then the average of the y's. Okay, now don't confuse that with the term between. Between means that it is somewhere within, so that means it's simply that it's located within a segment, or somewhere on a segment between the 2 endpoints, okay? So it's located somewhere within a segment. It doesn't necessarily mean it's the middle of it. So be careful when you see things that say it's between it. Between does not imply that it's a midpoint. There are 2 different things there. Midpoint means the 2 segments are congruent to each other. They are equal in length. Between does not necessarily mean that. Now, a segment bisector, okay? A segment bisector. Now, this is simply a ray, a segment, or line, which we come to bisects. Bi means 2, sect means cut. So it cuts a segment in half. A segment bisector is a ray, a segment, or a line which cuts a segment in half. Now, the place where it bisects the segment is called what? The place where it bisects the segment is called the midpoint. So the midpoint is not a segment bisector. The segment bisector is the ray, the segment, or the line that does the cutting, that does the finding of the midpoint. The place where it bisects it is called the midpoint. So the midpoint is that place where it's been bisected. Okay, so let's look at something here. So we've got segment DG here, okay? We've got segment DG. And notice that O right now is on DG. We've got O is on DG. So there's 2 things we can look at it. We have to be careful here, be very careful, and we don't assume something that's not there. So this says that DO from D to O is 6x minus 7. And from O to G, it's 5x plus 1. And the whole thing is 16. Well, if given what we know now, we're not going to rush to judgment. Does it say that O is the midpoint? Is there anything here that says that O is the midpoint? And the answer is no. Is there anything here that says that segment DO is congruent to segment OG? No. So because all we know is that O is between D and G, what does that mean if something is between it? Well, that means that the 2 segments add up to the whole thing, okay? This is called segment addition. segment addition. It says that when you add up the two parts of a segment, 6x minus 7 plus 5x plus 1, so those are our two segments. When you add them up, it's equal to the whole thing. So if we do that, 6x plus 5x, that's 11x. Negative 7 plus 1, well, that's a negative 6, equals 16. So all we've done is that's addition property, or that's just combining like terms. That's simplifying right there. So if we're looking at a proof, that's simplifying. So now we're going to add 6 to both sides. Is the addition property. We get 11x equals 22. And then we're going to divide both sides by 11. We find that x equals 2. So x equals 2. Well, plug that in. What does that mean then? That means that DO here, if x is 2, what's 6 times 2? 12. 12 minus 7, that means that this is 5. And plug it in over here. 5 times 2 is 10. 10 plus 1 equals 11. And OG is 11. So that tells us that, hey, this distance is 5, this distance is 11. Is that what you would have gotten if we would have assumed that it was the midpoint? No. If we would have assumed, said, hey, DG is 16, well, that means that half of 16 is 8, so this is 8, right? No, it's not 8. This one's 8. No, this one's not 8. Okay, so be careful when you're looking at these things. Make sure you understand the difference between midpoint, something being a midpoint, and something being between two segments, okay? So difference between them. Make sure you can distinguish those two definitions. So if we were to look at something, say that we had one that said that segment AF was bisected by ray XT. So we have segment AB is bisected by ray XT. Well, what does that mean? That means that segment AX is congruent to segment XB. It means the measure of AX is equal to the measure of XB, okay? So that's the difference. That's when we have a segment bisector. XT is a segment bisector. Then that means that we have a midpoint. That means that X is the midpoint of AB, okay? So there's some little clarification on segments there, as far as adding segments, as far as measuring segments, as far as knowing the difference in between and a midpoint. All right, so take this under consideration, look at them, bring questions to class, ask me anything you're not sure of, and I will see you back in class tomorrow.